In the next few lessons we're going to be looking at heat loss. In this lesson we're going to be looking at how heat is lost, and then the next lesson we'll look at what affects the speed at which heat is lost, and after that we'll look at how we can prevent heat from being lost in various situations. So when heat is lost from a body or an object, what's really happening is it's being transferred from a hot object to the cooler surroundings, and we've already looked at this. We've seen that there are three ways in general that heat is transferred from hot to cold. So we'll look at these in the context of this cup of hot tea that's been placed on top of a kitchen table. Now, in the case of liquids, there's a fourth way really in which heat can be lost, which we'll look at in a minute. Now, what is important to mention here is that whenever heat is lost, usually in a situation, it's not just one form of heat transfer that's taking place, but often 2, 3 or even 4 different forms of heat transfer can take place at the same time, and that's exactly what's happening here with this cup of tea. So the first form of heat loss or heat transfer is through conduction, because the cup is placed on top of a solid surface. So as a result of that, heat will be conducted from the cup into the table surface. Now, if the table surface is made of wood, we remember that wood is a particularly good insulator, so there's only going to be a small amount of conduction from that cup into the surface. But maybe we're in a workshop, for example, and we're having our tea break, and we've placed our hot mug of tea on top of a metal surface or an aluminium surface, like that, and now because aluminium's a conductor and a good conductor, that heat will start to flow quite quickly from our cup of tea into the aluminium work surface. So that's the first way that heat will be lost. The second way, again, will be through convection. The hot mug and hot tea warms up the air immediately above it. All right, so you got warm air here, right? The warm air expands. Okay, its volume increases, and assuming that the mass of air is the same, so we've got this kind of mass of air which is expanding, its volume's increasing, remembering that density is equal to mass over volume. Because its mass remains constant but its volume increases, that means its density drops, its density falls, and because its density is now less than the colder air above it, the warm, low density air will rise, okay? And heat will therefore be transferred by convection. Now, not only is conduction and convection occurring with our cup of tea, but also, as we learned in the previous lesson, everything that has a temperature, and this cup has a temperature of 60 degrees Celsius, and if that temperature is greater than the temperature of its surroundings, then it will be emitting more radiation than it absorbs. Okay, so it's also radiating heat. Okay, this is called thermal radiation. Okay, just to emphasize that, we mentioned before that everything that has a temperature is both emitting and absorbing radiation continually, but if the temperature of the object is greater than its surroundings, it will be emitting more radiation than it absorbs, so it will be losing heat through the emission of thermal radiation. So the third way is through radiation. Okay, so first of all we've got conduction, that's heat being lost through contact between the mug and the aluminium surface. Then we've got convection, and thirdly we've got thermal radiation, and then fourthly, the fourth method in which heat is lost from this mug, which really relates to liquids, is through evaporation. Okay, so we've got a hot mug of tea here, and the hot water is going to be slowly evaporating into the air around it. That means particles are going to be escaping from the liquid state into the gas state. Now, in order for them to do that, they need to acquire energy, and this energy is called latent heat, and that energy enables them to escape from that liquid state into the gas state. So the cup of tea cools down as a result of that, because the particles are extracting latent heat from the tea, enabling them to evaporate. Let's just make a note of that. So we can say heat is lost because the particles extract latent heat as they evaporate. Okay, so this process here really refers just to heat loss from liquids. Okay, you're very well aware of this fourth method of heat loss because, you know, when you go into the sea to swim and you're splashing around in the water and you come out of the sea, even if it's a hot day, what will immediately start to happen is the water on your body will start evaporating, and as it evaporates, as it does so, you know very well that your body starts to feel cold quite quickly because that water is evaporating from the surface. When it does so, it takes heat, latent heat, from your body in order for those water particles to change from the liquid state into the gas state, and that helps to cool you down.